well, I'm going to talk about OODB design in general, but I'm going to use Postgres as an example because, well, you can do this in Postgres, you can do this in SQLite. You cannot, however, do this in, what do we call it this week? Oracle Toy SQL? No. This talk should, in theory, have had slides, but I got distracted actually making the code work, and the code's much more interesting anyway. I don't know whether people are familiar with the terms STI and MTI. STI is single table inheritance, and MTI is multiple table inheritance. Now, your usual strategy for single table inheritance is you basically have one big-ass table that has got all of the attributes of both the base class and all of the subclasses. And then you have a class field, and then you make all of the attributes nullable, all of the other columns nullable, and if they're not valid for that class, you just leave them as null. This is heinous, of course, because if you then need to have an attribute that's genuinely nullable, you can't actually tell. And you've got no way for the database to enforce that it's got the right attributes for the class. It is, however, very much possible to develop performant effective systems using this model. And if anybody's ever played with Tangram, that Mugwump Sandbele maintains for Perl, that's actually the strategy it does to do transparent OODB stuff. But I looked at this and went, nah, this is kind of horrible. So I also looked at the Postgres table inheritance stuff. But the Postgres table inheritance stuff is a little bit odd, because you sort of have a table that inherits from another table, but then if you select from the superclass table, it will return data from all the subclass tables, but you can't actually tell which one it came from, and then the tables effectively look like copies of each other, and so you have to re-add all the foreign keys every time, and it all just gets horrible. It's very impressive for a built-in thing to the database, but it does kind of suck. So your same strategy, if you've got a database rather than MySQL, is to go for multiple table inheritance, where you have a table per concrete class. If you're modeling in an elegant way and using thinking in terms of the most stuff, you'll also find that you often end up with a table per role. But I'm not going to go into doing that because this is complicated enough as it is. So the multiple table inheritance approach, the way you tend to start...
Can you make that text bigger? Or
yeah, I can.
Fantastic.
I'm going to do that in a second. Right, can we go with that? Is that legible?
Yeah.
Good. Right, so what you end up with is you create a table for the superclass, then the subclass, you share the primary key up. Now, in this case, I'm using an auto-inc ID because all of the examples of this I've dealt with in the wild have needed that. There's absolutely no reason that you couldn't use a different type of primary key for this, but again, it would make the example even more stupidly complicated. So at that point, the thing is that if you're going to do that, you're then in a situation of, well, we need to select from two tables, so you end up generating all sorts of gnarly joins and doing multiple inserts and multiple updates. And it's so easy to get wrong. And we thought, well, what if you create a view that sits over the top? And David Wheeler, the guy behind Bricolage, had been working on a better OODB system, which is still on cPanel as object relation. And he generated views for this. And in Postgres, the way he did it, this is an example from a different presentation, which was a client app. So you end up with a data table per class, and then you foreign key up to the superclass, and then you just create a view that selects from both tables and does the join for you, and the Postgres optimizer can unroll that comfortably. And the Postgres optimizer can unroll some scary things comfortably. Part of that presentation was actually a query where the explain analyze output was 2 screens even when I took the text size down to about 2 pixels per line. And Postgres still manages to execute it in about 1/10 of a second. So Postgres views are not updatable by default. However, Postgres has a rule system which allows you to do query rewrites. So you take the insert query and you rewrite it to do an insert into trading entity, and then it can do an insert into hotel group and use the curve val of the sequence that's feeding your primary key for trading entity, and so you get the matching record in the hotel group table. Now, that implementation, which I pretty much nicked wholesale from Dave Wheeler, turns out to contain a rather subtle and upsetting bug. Your subtle and upsetting bug is rules are a pure query rewrite. Because they're a pure query rewrite, if you have something like an insert select or an update that hits multiple values, then what it actually rewrites it to is insert into the superclass table, and then the inserts in the subclass table. At which point, of course, your curve val, because it's static, it tries to insert 3 records into the subclass table, all corresponding to the last one it inserted into the superclass. And your data just went horribly, horribly wrong. You get all sorts of integrity violation fun with updates and deletes as well. Now, for the last project, we worked around it in DBIC, basically by going, well, sorry, we don't have time to rebuild this, let's just call update all and delete all instead. Oh, I've actually got somewhere, yes, I have an actual example of these views. The other fun part of this, of course, is you see what I mean though, if you've got 3 inserts, it will rewrite into that 3 times, and then that 3 times, and then that curve out fucks you. And it gets kind of fucking messy to generate these as well. This one is actually maintained by hand because we didn't have time to automate it in the scope of that project. And that is, let us say, not what you would consider a fun time. So, how do we get around all of this? Well, you can rewrite the rule to anything you like. You have to rewrite you have to do a do instead rule rewrite, because obviously if the insert actually tries to hit the view, Postgres is going to say, that's a fucking view, what are you trying to insert it into, and throws you out. But, do I have a job open for this? Yes, of course I do. So, create a view for the superclass, and then you have a function that does the insert into the table, and now you can rewrite your call on this function. So if I hop down my, if I hop down here, yeah, just hop there. You can see what you end up with is superclass table, replace function for the super insert, view, and then you'd use the rule to call the function, because the return value of something that's being used for an insert statement does not matter, at least not for our purposes. At which point the super insert can do that, and then you go on to create a table for the subclass, have the function insert into super, and then now, because we're in the body of this function that's going to be executed once per insert, curve val is stable and actually contains the right thing. But it's still too much typing. And in fact, I will quite happily admit that today, when I was first writing this, I started off thinking, I'll write a simple one by hand to demonstrate as an example before I go on to automate it. And I got about 10% of the way into that and went, no, bollocks to this, I'm writing the code first. So what we have is a little specification. Yes, I have made the traditional newbie mistake of writing my own parser for my own little custom syntax. That's because I'm lazy, that's because I was more interested in generating the right SQL. You can all laugh at me later when it goes horribly wrong the moment I try and refactor it. So you take that definition information, break it up, record the main table one, record the super if there is anything, record the columns, and then get into a bit of fun. One of the joys of regex matches is a regex match in list context returns all matches. So you can actually do sort of the equivalent of a substitution regex if it was one that was just going to chop some stuff out by just sticking the match in the middle of the map because you've got one capture. At which point, if you look at that, it pulls the column name off the front. So you end up with the names in there. And you also need to remember what your top level superclass is, because that's the one that contains the sequence that you're going to need. And of course, given it's a serial column, the name of the sequence is deterministically generated from the table name, so we know we can go back and find that later when we need it. At which point, we can go, well, if we've got a superclass, we need to PK the following keys to it. If we've not, just whack a serial together. Drop the create table in and throw the column definitions through raw. The idea here being that that initial format eventually should look mostly just like a create table. Although if you think that parsing a create table statement is fun, then I'd please invite you to take a commit bit to SQL Translator and help fix some of the parsers in there. So, check to see if you've got a superclass. If you have, you're going to need to insert into the super table first. Generate out the names, and then, given the super, whack the ID on the front as part of the insert into the subclass, and then generate out a function that produces the insert. Generating the view should be reasonably obvious. Not from the code, you saw the final product. The final product should make sense. One of the essential rule for writing code generators: make the final code it generates pretty. If that costs you some pretty in the generation code, it costs you some pretty in the generation code. Because if your generated code is ugly, when you screw something up, you will not be able to debug it. And given the generated code is what's going to execute in production, being able to debug that is much more important. You can always spend an hour screaming at the generator later. So, at this point we realise, well, we're going to want to generate multiple types of function. So, 93A, was that right? Yeah, there we go. I didn't get that very marvellous. So, we chop it across and start generating our update bodies. Now, it doesn't really matter what order you do the updates in. I tend to prefer the idea of updating the superclass first. I also tend to very much believe that if you're in this sort of system, one of the reasons you should have an auto-link ID key is that you don't want to piss about changing the primary key. Changing primary keys can be a pain in the ass as it is, but in a system like this, it's then got to cascade to n different tables, and then you've got... it enters into the realms of, I do not have the energy to deal with this, and I would recommend you take the same approach. So your output at this stage, you end up with an update function. That one's boring. Where's the interesting update here? Updates the super setting the records. The reason for prefixing all the column names with an underscore is that in your set expression, the identifiers from the table are in scope, so you need a separate name, and it's much easier to just have the name, the underscore, and the column name. Makes it reasonably predictable and reasonably easy to generate. And then final stage with a little bit of refactoring is to generate a delete. And in this case, you have to do the superclass one afterwards because you've got a foreign key to the superclass table. So you have absolutely no choice. You have to make sure you delete from the subclass table first. Otherwise, you're going to end up with an integrity violation. and the delete trigger just passes the ID down because you don't need anything else to delete the row line. And so the final output at that point looks something like this, where if we go to the delete, notice that for the update we have to pass we want to pass old.id. The reason for doing that is if somebody does mistakenly try and update the ID in a query, it's just going to throw away the new ID rather than breaking your data. And the delete just passes through the old.id to the routine, which then deletes from the subclass table and then deletes from the superclass view. The reason for doing the view is it means you don't have to duplicate all of the logic in the subclass views that you've already handled in the superclass. Basically just not worth it, and it maintains encapsulation all the way down. Each subclass, all it knows is, I have a table for my own attributes, and I have a view that represents my superclass. And it doesn't care about anything else, which leaves you with things being much easier to refactor later. And so, if I then run that into it, into a Postgres DB. What do I want to do? Right. Yeah, that worked really well, didn't it? See, as soon as I get on to trying to do a live demo, it goes wrong. However, that should work. That one's we want to take that from the oodb file handle, and then I can font it in. It still hates me because I'm a moron. There we go. So we make 2 inserts. Insert a couple of extra records to have a look later. And if we select from the super table, we've now got the IDs generated out and that column filled. Select from the subclass table and we can see that that data has been filled in, but the view is reporting both as if it was a single thing. We can do an update on the super and update one of the sub-records, and then if you have a look, the super data has been updated and is shown correctly, and the sub-data still has that. And if we delete a couple of those records, you can see that it's deleted the records from the right table and nothing has actually blown up. And I will put the code up on the web somewhere tomorrow. But I hope that was a reasonable illustration of why this technique actually works and is relatively sane, and perhaps most importantly, a really good way of working around the fact that DBIX class's ability to do object DB stuff, to do oodb stuff natively currently sucks ass because I need to refactor half of it. Does anybody have any questions? Okay, that was either really good or I confused the arse off the lot of you. Never mind. Thank you very much.